Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 2370, longest ideal subsequence. So you're given the string S and you want to find the longest subsequence that every single character that's adjacent, every two adjacent letters, has an absolute difference in the alphabetical order less than or equal to k. So let's go ahead and break this down step by step. So in this case, notice how every single adjacent letter has a difference less than or equal to k, and that's in terms of alphabetical letters. So let's go ahead and create all the letters first. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Hopefully I got that right. So for I in range length letters, let's go ahead and map the letter itself to the index. Cool. And then the answer is going to be at least 1 because any single letter is less than or equal to k because it's going to be 0, and you can see k is not going to be negative. So we know that to be true. And then now let's go ahead and do some kind of a dynamic programming approach. Let's build backwards. Basically, we're going to loop backwards. So let's say we have A, C, F, G, B, D. So we're going to start with I, and then we're going to start with a J, and then we're going to compare if the difference between J and I is less than or equal to K. If it is, then we can go ahead and update our DP array, right? So we're going to build a DP array, and then at the end we can just return max of DP instead of answer. So for I in range n minus 1, minus 1, minus 1, and n is just going to be length of S, and let's just call this current is going to be list of S. Okay, so now as we go back, again, we're just going to compare every single character to the left of I with I. So for J in range, I minus 1, minus 1, minus 1. So if cur of J, so the difference has to be the absolute difference of D cur of J minus D cur of I. So if that absolute difference is less than or equal to K, then we can update DPJ to be the max of itself and DPI plus 1 because we're accumulating the results that we've seen as we go left. So that's one more answer. So let's go ahead and run this. So this works. Let's submit it. At least it passes these test cases. So this is an n squared approach, right? So it's going to get time limit exceeded. And so the way I came up with to get over this is to first notice that we're only dealing with lowercase letters. So there are only 26 letters, right? So why don't we just go ahead and first keep track of all the indexes that each letter occurs, and then because we're trying to find everything to the left of I, then let's just go ahead and remove as we see, and then at most we're going to have to loop through 26 letters. So that's a lot better than a very big array. So let's go ahead and go through S. So for I, C, enumerate S. Let's go ahead and append the letter to the index, and then at the end let's go ahead and run a bisect left inside of DD cur of I, which is this current letter, right? And that's going to find where I exists. And so then if BL is less than length of DD cur of I, because this is a list, right? So we're going to have, for example, A, we're going to have 1, 2, 3, 4, 5. Because we're going from left to right, we know this is going to be an order. So then we can find I's index and then pop it if we have to. So then in that case, DD cur of I, we're going to delete index B left from it. Okay, so now we don't have to do this, and then we can just loop through DD instead. And then because we're trying to find the longest ideal substring, right, we want to find the index that is farthest from I in whatever we have left. So first of all, let's calculate the difference, which is going to be absolute difference of D of the difference between the letters. So cur I minus D of kk. So if the difference is less than or equal to k, then we can actually go through this list. And so we're going to go ddkk, and we're going to say if index is less than I, then update our dp index to be the max of this and dp of I plus 1, right? So one more than whatever we've seen to the right so far in terms of I. So let's run this. Okay, submit it. So this is still n squared because this is going to be slow. So if we're looking for the longest difference, why don't we just take the biggest one, because this is already sorted, right? So then we can just say last is ddkk -1. So if last is less than I, then dp of index or dp of last is max of dp last, dp of I plus 1, so we don't have to scan through the entire value list of the key, right? Okay, so okay, so if not dd cur of I, then we can just delete it. So we don't have that key anymore if it doesn't have anything in it. Okay, let's go ahead and submit it. Okay, so that's not correct. Let's see what's going on here. So we know that we just want to find anything that's less than I. So if it's less than I, why don't we just run, because we don't know if this index is less than I, right? Even though it should be deleted here. Let's just run another binary search on ddkk to find the location of I, and then -1, because bisect left gives you the leftmost index of like the very first left appearing value of I, and then -1 is going to be the value that we want. So then if BL is less than length of ddkk, and then if BL is less than I, then we can just go ahead and say value or last is ddkk of BL. So that lists index, which results in a value. Okay, let's try this. No? Okay. So, so if last is less than I, then we do this. Okay, let's use this test case. Okay, submit it. Cool, and there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.